So in the first section of these notes, we're going to be discussing how to deal with significant figures again, because the new chapter is heavily focused on math operations. So you need to be able to remember how to deal with significant figures like we were doing back in chapter 5. So there's two sets of rules we're going to talk about: the addition and subtraction rule and the multiplication and division rule. And the reason we need to review these is, as we do math in this chapter, every time we do math in this chapter, you have to either round it appropriately using whichever rule. So the addition and subtraction rule, we go by the number of decimal places or place values that are good. And as you can see right here, after the 3, there is no value written down. We don't know what value is there. So we can't really add 6 plus this unknown value. We can't really report that there's a 6 there. We don't know that that's actually a 6. We do know that the 8's pretty good though. So what we're going to do is we're going to round this value to 16.9, which only shows the two first values that are good significant figures, and then the next one, the 8, is the estimate. So we got to get rid of everything after the 8. This other one, we have 4,200 with no decimal, so we don't really know that these two zeros are significant figures. We know that the 4 is good and the 2 is the estimate, and we're adding it to a value that is really well known. But again, when you do an unknown value plus 5, we don't really know this is a 5. We don't really know that's a 3. We can't actually make those claims. So we have to round everything that comes after the 300 place. So that 35.89, that all needs to be rounded away, and so our answer would be 4,300. But we don't want to put a decimal down, because then that would turn those zeros back on. We want it to be 4,300. We could also write this in scientific notation to get rid of those trailing zeros so they'd be less confusing. So 4.3 times 10 to the third power, that would put it in scientific notation and only showed the two sig figs we wanted. With multiplying and dividing, we go to the least number of significant figures. So we have to look at the values we're multiplying and dividing, and we have to figure out how many sig figs they have. This first value, 2.500, has 4 significant figures, while the second value, 4.0, has 2 significant figures. So our answer, we only want to show the first 2 good significant figures. All of the other values, you could even write a million zeros after that if you wanted. All those other values need to be rounded off. So you only want the 10 and the decimal, because we really only have 2 good values. Because see, we have a 4 and the 0 is an estimate, while on the other value the last 0 is an estimate. Excuse me. So we're going to round our answer to 10 with a decimal, so that only shows 2 sig figs, one that's well known, and the second value is our estimated value, just like the smaller of the 2 we were multiplying originally. In this second example, we're dividing 3.50, which is 3 sig figs, by 5.001, which is 4 sig figs. And so since 35.0 only has 3 significant figures, we can round our answer to 7.00, which also only has 3 sig figs. We have to get rid of anything that comes after the second 0 so that our answer has the same number of significant figures as the lesser of the values we're either multiplying or dividing. So here we went with 3 because the 35 only had 3. So we're going to be doing a lot of multiplying and dividing in this chapter, so you need to make sure you remember these rules. Again, they are: if you're adding, you pay attention to where the decimal places kind of run out. If they're multiplying and dividing, you go by sig figs. The other thing we did in chapter 5 was dimensional analysis. And dimensional analysis is a method of using units to convert from one unit to another using equivalencies. And up here at the top we have tons of equivalencies. These are 10 equivalencies you might have used in your life. Not like the equivalencies we're going to use in this chapter, but here we go. Here's yards and meters. This is an equivalency you could find pretty easily. On this sheet here, the equivalency says 1 meter is equal to 1.0936 yards. And so since this has both yards and meters, this equivalency has both yards and meters, we're going to use it to convert to find the answer to this question. Now the tricky part is making sure you set up the equivalency correctly. You have to make sure that the equivalency cancels out the units of the given by putting the equivalency's units on the bottom that match up with the given. So I would put yards on the bottom to cancel out the yards that were given, and meters on top so that they don't cancel out. So that's yards on top versus yards on bottom so that they cancel, and meters on top so they don't cancel. And then once I have the units set up, I can go ahead and do the math. In this case, we have 487.3 yards times 1 meter divided by 1.0936 yards, and the yards end up canceling but the meters don't. And let's go ahead and see what this would look like in our calculator. $487.3 divided by, I'm going to skip the times 1 in my calculator because that doesn't really impact the math at all, divided by 1.0936. And my calculator, if you look at this right here, is in scientific notation mode. See right there, that e to the second, that means times 10 to the second. So this is 4 times 10 to the second, which would be 400. You could change it back and forth between scientific and normal mode. Here I'm going to change it back to normal mode. And now the answer comes out in normal notation, 445, blah, 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 blah. And this is a really long number. And it would be irresponsible to write down this whole number and claim that it was the right answer, because our given 487.3 is a measured value with only 3 good sig figs and 1 estimated, so it's got a total of 4 sig figs. This answer cannot be magically better than 4 sig figs. So the first 3 are good, the 445. The 5 is where our estimation begins, so everything after the 5 has to be rounded away. So what we have here is 445.6 meters. Everything else has been rounded off to reflect the proper number of significant figures. Now we're doing this because a lot of this chapter is going to be using equivalencies. Here's an example. We're going to have to use a couple of equivalencies to figure out what exactly the right answer would be. So I'm going to go up. I'm going to have liters and gallons. Let's look through these equivalencies, see if we can find liters and gallons together. Now we've got liters and quarts here. Let's see, what else do we have? We have quarts and pints. That's not really going to work. We have gallons and quarts. So if we can go gallons to quarts and then quarts to liters, we could do this problem, but it would take 2 equivalencies to get it done. So I set it up. I wrote down gallons first. That's my given on the top. And how do you cancel out a given? By writing the same unit on the bottom in the next step and writing its conversion factor on the top. So if I've got gallons, I've put gallons on the bottom, and the conversion factor is 1 gallon is 4 quarts. So I put 1 gallon on the bottom and 4 quarts on the top. Now that I've switched to quarts, I can use the second conversion factor, quarts to liters. But now gallons is gone, so quarts. How am I going to get rid of quarts? I have to put the unit quarts on the bottom in the next step, and the unit that it's equivalent to on the top. So I say 4 quarts. Here we go. 1 liter is 1.0567 quarts. And I'm going to liters because that's what the question asks for. I could have gone to pints, I could have gone to cups, I could have gone a lot of directions. But this question specifically asks to go to liters. And again, I pick up my calculator, and the calculator spits out a very long answer. And I need to think about the significant figures as I round this answer. I have 0.653 gallons. That's only 3 significant figures in the given, and this answer has what looks to be like 9 or 10, I don't really know. But so I can only show 3 significant figures, 0.653, so we're 2.47, everything after the 7 has to go away, has to be rounded off. So, since the number after 7 is a 1, I'm going to just drop everything off, and my answer is 2.47. You need to practice doing dimensional analysis because it's a very key skill in this chapter. We're going to be working with some new units that are different to you. They won't be identical to ones you're used to, so you're going to have to be good at dimensional analysis and using conversion factors.